kids. I am going to talk to you today about triangles. We're going to review a little bit what angles are, the different types of angles, and begin our reviewing of polygons. You did this with Mrs. Vaughn when I had surgery a couple weeks ago, but I feel like there's enough time that's gone by in order to go on with this unit that we need to continue first going backwards to go forward so you aren't confused. Here we go. What's an angle? An angle is when two lines or rays meet at an end point or a vertex. So we have rays here, they're meeting here. A line is something that is a straight line that does not have an arrow on it, whereas a ray has an arrow on it. Think of the sun has rays coming out at you. And then an endpoint or a vertex is the point, the spot where those two rays or lines would be meeting. There are different types of angles that we're going to be talking about: an obtuse, an acute, an obtuse, and a right angle. We know those by measuring their degrees. So here are showing the degrees between this ray and that ray is 45 degrees. Between that one and that one is 90. This one's turned different than that, but they both are the same amount of degrees. And then this one here is showing between those two rays 120, 72, and 23. Now, this comes from a circle is made up of 360 degrees. So we know that that is how we are going to measure our polygons. And polygons have angles, they have vertices, and we need to understand those. So the first type of angle, an acute angle, is the small angle. It's smaller than 90 degrees. So think of it as being very cute. It's little itty bitty. So these are all less than 90 degrees. For anywhere from 89 degrees down to 0 would give you our acute angle. The next type of angle that we're going to look at is one that's more than 90 degrees. That is an obtuse angle. So it's bigger than 90 degrees. It's anywhere from 91 degrees up to anything bigger than 90. So then we have a right angle. That is like taking a piece of paper and sticking the corner of it in there. No matter how it's turned, even if it's not straight up and down, it can be angled like this, and it still is going to show 90 degrees. That perfect square in there. Squared off corner, we'd like to call it. So all polygons, I told you we're going to talk about polygons. All polygons are made up of angles put together, and they make a shape. But that shape has to be closed, and we'll talk about that in a moment. And it has to have all the lines being straight, and none of those lines can cross. So they meet and end at an end point. Here are some shapes we're going to look at: open and closed. So this one here, if this were a fence, my puppy were running around in that, he couldn't get out. There are straight lines. Where I started is where I end, right here. You start and end at the same end point to make the completely closed shape, and they're straight lines. This one here, I have a nice open area. My dog would be getting out if this were a fenced-in area. Not a polygon. This one has curved lines. It is closed, but it's curved, so it's not a polygon. This one crosses over each other. Even I do have two closed areas and I have all straight lines. It's still not a polygon because of that. Here, straight lines, begins and ends at one point. It's closed and no curves. That is definitely a polygon. Here, look at all these curves. Doesn't matter that it's closed, they're all curved. So that is not a polygon. Here, and my little screen is going over that, but you can see it goes straight through. That is a polygon. Straight lines closed. All right, we're going to give ourselves a little quiz. Polygons have sides that are curved? No, never. False. All closed shapes are polygons? Well, we did see some that had curved lines, remember? No way. That did not work. So that is false. Open shapes are never polygons. That is true. If it's open, it can't be a polygon, even if they're straight lines. Polygon must begin and end at the same point. That's true, because it can't be open at all. And a circle is a closed shape, but it is not a polygon. That is true, and that's because it curves. We need straight lines. So we're going to talk about our first polygon, our triangles. And a triangle is a polygon with 3 angles and 3 lines. So there's 3 endpoints. There are different types of triangles that we are going to look at. We can categorize them either by their sides or by their angles. So first we're going to look at how do we name a triangle by its side. First one is an equilateral triangle. All 3 sides are the exact same length. This side, you can see that these 2 are the same length and this one isn't. That's an isosceles triangle. Think of the S and then a different letter and then the S. So we go, S, different letter, S. That is an isosceles triangle. And when all of 3 sides are different lengths, that is a scalene triangle. Now, a scalene triangle is like a scale. So a scale, you go on it and you may weigh one weight and your mom might weigh a different weight and dad a different one, and maybe your puppy or your brother or your sister weighs all different weights. So think of a scale for scalene. It's all different lengths in this case, not weights. All right. Next way we can classify triangles by their angles. So we talked about the angles before. If it's got even, for this case, it's a acute triangle, so it has to be smaller than 90 degrees. That makes it that this is an acute triangle. If it has even just one obtuse angle, only one, it means that is an obtuse triangle. And if it has only one right angle, it only needs one, it's a right triangle. All right. I am going to hide myself here and we're going to take a little quiz. So if we look at this, how would we classify this? This shows us that it is definitely a squared off corner. I could stick my piece of paper in there. That is a right triangle. This, if I stuck a piece of paper in that corner, I could tell that that corner is larger than 90 degrees, so it's an obtuse triangle. This one here definitely has an angle that is greater than 90 degrees. That is also an obtuse triangle. This one has one that looks close to a right angle, but I don't see that little square in it. So I'm going to put my piece of paper in there. You put your piece of paper in there, in that corner. And oh man, that is a little bit smaller. It's just my paper's coming up here. It's a little bit smaller than a right angle, so it's an acute angle. Here we have one that's exactly a right angle. That is a right angle. And these ones right here, all 3 are smaller than 90 degrees, so it's an acute triangle. Let's look at categorizing it by sides. This one here, all 3 are the same length. And so we have an equilateral triangle because they're all equal. Here, 2 of them are the same length. So we think of that SOS. It's an isosceles triangle. Here, they're all 3 different lengths. And in that case, we have a scalene. Think of different weights. Here, 2 are the same length. In that case, we have an isosceles triangle, SOS. And then we have one with all 3 different lengths. And in that case, it is a scalene triangle because scale, we weigh different weights. These ones all have different lengths. And this one here, all 3 are the exact same, so it is an equilateral triangle. All right. You are going to get some practice today. In your Google Drive, you're going to find triangle homework. Then you're going to try all the activities similar to what I did. If there's a red circle, you're going to drag it over the right word. If you need to move an object or write in words, you'll be able to figure that out real quick. But then you're going to share it with me when you have finished so I know you're done and I can check it. Remember, you can always replay this lesson to check to see if you are correct or if you're a little confused on one of them. So good luck. I will talk to you tomorrow. Bye.